You're welcome to today's class. We are still on function. So last class, I taught you nested function, and I told you I was going to teach you trampoline. Now, today we are going to do trampoline, still on the concept of nested function. So I'm just going to write a program to explain the concept to you. I will explain the concept of Jesus and his disciples after he left. I will explain the concept of Elijah and Elisha, right, using this trampoline. So I'm going to teach you this using the concept of parent-child. Now, the ANSI C does not allow for parent-child relationship, meaning you cannot create a function inside another function. ANSI C will not allow that. But because of the concept of GCC compiler, no, it has an extension that allows you to create a function inside a function. And I taught you that in the last class. Now, I am going to teach you what happens when the parent class is no more. How can the child class still survive and be able to access the memory of the parent class? That is the concept of trampoline that I want to show you today. So without wasting much time, let's start. Now, the first thing I will do is to write my include stdio.h. This is my preprocessor directive to allow me call the printf function. Now, the next thing I will do now is to type. I'm going to use a keyword in C, type def. I'm using it to create an alias for the function pointer, right? So I will say type def, right? And then I will create an alias. So I will say this, first, the return type is void. So what this means, I will explain to you. And I will do this. This is my asterisk. And then I will say function underscore pointer, right? Function pointer. So now I'm using this type def to create an alias for a function pointer. This function pointer is pointing to a function that does not have a return type and does not accept a parameter, right? So I have created this. So this is like creating a different realm. I will teach you the concept of parallel reality in this class. You will understand it. So just watch. So type def, I've created this. Now I'm going to create my parent class. So the parent class will be void, right? So let's just name it parent, which is my outer function, parent. Now this parent class is going to accept a parameter, but the parameter will be a pointer, right? A pointer function. So this pointer function that I've created, the alias, so I'm just going to say underscore pointer. Then I will do this. Let's create this storage. We'll call this storage. Okay. Then, because this parent is a function. So this parent is standing as my outer function. Now, this parent, I'm going to create a thought. So meaning I'm going to create a variable for this parent. So I will just say int. Then let's call it secret. And I will assign 33 to it. Right? I'm assigning a value to it. Then now I am going to create a child function, which is the inner function. Now, trampoline is a technique that is used to call a nested function indirectly. That is the meaning of a trampoline. It's a programming technique that is used to call a nested function indirectly. In the last class, I showed you how to call a nested function directly, meaning the parent is there, so you can access the child. Jesus was on earth, so he can give power directly to the disciples. Now, what happens when he left? How could the disciples access the same power? While Elijah was on earth, Elisha could access the power of Elijah. But when Elijah left, how could Elisha now access the same power of Elijah? Even more. he dropped a clock for him. That is a trampoline. So Jesus Christ said, I'm going to give you something. I will not leave you without anything. And that thing is what? The Holy Spirit. So that becomes the trampoline, which means a portal through which you can access the realm of power to still be able to manifest everything as if I am here with you. You understand me? So that is what I want to show you in this. And that is the concept of what? Trampoline. Now I have created in secret, which is the power of or the variable of this parents class. Now I'm going to create an inner class. So void inner, or let's call this child, right? Child. Then this child is not going to return anything, but it's just going to print a value. So inside it, I'll say print f, and I'll say secret, right? Percentage d slash n, comma, secret. So I taught you in the last class what kind of technique is this, where the child is able to access the variable of the parent. This concept is called lexicoscoping, right? Lexicoscoping. I told you in the last class. So that is what enables this child to access the variable of the parent. So now I have created my inner class, which is my child class, that accesses the variable of the parent inside the parent class. Now, the next thing I'm going to do, so I will close this. The next thing I'm going to do now is to create this pointer, which is what? This asterisk storage. I'm going to point it to the address of this inner class. So what I will do here, I will say storage. I'm pointing it to child. To child. So I am pointing this to child. So this is my function pointer that I'm pointing to the address of this. So that I have done. Now I'm going to close my parent class. So which is this. So I've closed my parent class. Now I'm going to create my main function, which is the soul. And then I'm going to call this parent class under my main function. And then I will supply an address to it. So what do? I will come here, I will say int main function, then this. So the first thing I will do is I will do func pointer, and I'm creating a variable. I'll call it saved. So I'm creating a variable saved, but this is not an ordinary variable, right? This is the pointer function. Because of this rem, so this I am creating this save in this rem, which is what? A type def. I've used it to create an alias. So this is saying this one func pointer save is the same thing as saying pointer. You write here void, right? Pointer saved. So this is the same thing as this. So this is an alias. I created the alias for this guy. So that is just what I want to show you. So I have created a function pointer here. So it's not just an ordinary variable. Now I am going to call this parent class. I'll say parent. Then I'm going to supply the address of this save. Right? So this is call by reference. I taught you that, call by reference. I'm supplying the address of this guy, right, to this place. And then it is going to come here, meaning I'm pointing this to the child. So I can now call this save here. I'll say save. Because this is a pointer function, I can call it as if I'm calling a function directly. Now, I don't know whether you are still seeing down, but I'm supposed to write the return, which is what? Return 0. Then I'll close my curly bracket. I hope you are still seeing. I don't think you are seeing this place. So I'm just going to wipe it off, which is what? So what should be here? What should be here? Just what I will put here. So which is what? Return. Return 0. Then my curly bracket for my function, I'll just put it here. So I've closed it, right? So let's explain this program. Now I've created my type def. This type def is what I used to create an alias for my function pointer, which is this. So I have created the function pointer here. So the first thing I do is I create the parent. This is the parent. That is the parent. Now this parent is expecting a pointer variable. So I am calling this address here in my main. And I'm supplying the address of saved. This is a function pointer. So I'm supplying the address to this place. And then I'm pointing it to this child. So the first thing that happens is a memory location will be created like this, right? For this parent. A memory location will be created for parent. Now inside this parent, another memory will be created for int, right? That is for secret. For secret. Then another memory will be created for this child. Memory will be created for child. So in this place, 33 will be assigned here. And then this process will take place inside this place for the child. Now, what happens here? The trampoline. Because I'm using a GCC compiler, it will, behind the scene, you are not seeing it, it will create a duplicate of the whole of this. It will create a duplicate of the whole of this and put it somewhere else. That is like a parallel reality. Now, when I call the parent, because this parent class function is here, it has been created. When I call the parent here, this memory address will be created, right? And then the address of save, which is a pointer function that I've created, will be given to this storage. Once that address is given, it will come in here, it will create a memory location for secrets, and to put this value, which you have seen. It will create a memory address for this child, which is also here. Then, this, my pointer, which I have created here, which I have supplied to this place, that is, this saved, is my pointer, which I have given to this place, through call by reference. This saved is pointing, is coming here as call by reference. That is it here. So it is now pointing to the address of this child. It's pointing to the address of the child. Now, behind the scene, a parallel reality, meaning a duplicate of this entire environment of the parent, to be created. Now, it will return back to this place. The moment it leaves, it returns from here. When it encounters this, the last curly bracket, it will return back here because I called it here. Everything about this will disappear from the memory, meaning it doesn't exist again, meaning the parent is gone. So everything that was created inside the parent, including the child, gone. But I am now calling the child here because this my saved function, which is this one, is a pointer, right? Is a pointer to the child address. The parent has gone and has returned. When the parent returns, everything about that parent in memory will disappear. So it means the parent does not exist again. So everything inside the parent, including the child too, will stop to exist. Now I am now calling the child here. Under normal circumstances, I am not supposed to see anything again. It will throw me an error because the child doesn't exist independently of the parent. But because GCC at the back end has created a trampoline, has duplicated this environment somewhere, it will create a trampoline that when I now call the child here, right, that trampoline is like a springboard. It will hit on that springboard and it will catapult you to the location where you have that duplicate. So I can still access the child. And when I access the child, I will still be able to access the thought of the parent. And I will still print out secret. I will still print out secret 33. Right? Secret 33. Now, how is he able to do that? Because a trampoline was created to allow me to access the new location of the duplicated environment. So when Jesus Christ said, I'm going away, but I will give you the Holy Spirit, meaning I'm creating a portal through which you can access the Father. So the whole concept is, this is man, right? Now, this is the Holy Spirit, right? Now, this is Jesus, and then this is the Father. So this is just a path for you to access the Father. Now, this is the trampoline through which you access Jesus, and then you access the Father. So in networking, I'm bringing that in here. This is called point-to-point. Point-to-point connection between the Holy Spirit and Jesus is a point-to-point connection. So you are accessing the Father through this point-to-point connection. So this is the trampoline. So when Elisha told Elijah, I needed the double portion of your spirit, he said, if you see when I'm taking away, you will have it. When he was taken away, he dropped the clock. That clock is the trampoline. So that clock was a portal to the environment that was duplicated, to the environment that he was using. Meaning, where was he getting the power from? I have to create another environment for Elisha to be able to access it as if it is accessing Elijah himself. So a trampoline is a programming technique that allows you to call a next step function even when the outer function is gone, is no more. That is what I want to show you. So you create a pointer alias. This pointer alias is what you use. This is the name saved, because you can see this pointer alias that I created. So I am creating this save in this realm, right? And then I am supplying the address of this to this through call by reference, meaning anything that I change here will affect this parent. You can watch my call by reference to understand. Then I'm now pointing that to the address of the child that has been created here. But behind the scene, a parallel universe will be created. So even when this parent is returned back here and the parent disappears, everything is gone. There is still a duplicate. Now, when I now call the child here, through that trampoline, I can access the address of the child, and I'll still be able to carry out what is here and access the parent because I did it through a duplicate. That is what I want to show you in this class. So let's go to code block. Let me run this program for you to see. Okay, so this is our code blocks, and this is the program that I wrote on the board. So I've explained everything on the board. So I'm just going to execute this program for you to see the output. It will print out secret 33. That's what it will print out. So you see, this is the output. Secret, which is this one that is written in the string, that is string literal. Then this expression is expecting the value from secret, and secret is a variable under the parent. So secret 33. That is just what I want to show you in this class of trampoline. So in the next class, I'll be teaching you callback function. So we'll see in the next class. Bye-bye.